Hey AAF students. In this video, I am going to be going through topics and objectives that you have learned and explored throughout Unit 2. This is like your Unit 2 review video, so there is no new content in this, but I really encourage you to work through this and think about maybe, do you have any questions that you have about this? Because the next time that we see you, we have our Unit 2 assessment on linear and absolute value functions, right? So everything that we've done in Unit 2 so far. So this is practice and review of those skills. So the first thing that we did was we learned all about linear functions, right? Or we reviewed all about linear functions. We learned different forms of a line. You learned point slope, you learned slope-intercept, and we learned standard. And if you recall, point slope was y minus y1 equals m times x minus x1. Or sometimes you would see it as y equals m times x minus x1 plus y1, right? So this is what we referred to as graphing form, because this is where we refer to the transformation. So this is an important one to us. Slope-intercept form was y equals mx plus b, where you have the slope and the y-intercept. This is the one that you are, or were at least most likely, most familiar with, because this is emphasized the most in previous courses. This is my favorite. And then standard form, which you likely did not really work too much with in the past, but this is ax plus by equals c, or ax plus by plus c equals 0. And you do need to remember that these are equations. So I would be mindful that you're not getting like really happy that you finished and you forget to write the equals 0, because then it becomes an expression, right? That changes the entire meaning of what you're doing. And the important pieces to remember here are that a, b, and c are all integers, and a has to be a positive integer. So you're not going to have fractions. A is not going to have, your x value is not going to be a negative leading coefficient. So a has to be a positive integer, and b and c just have to be an integer. It can be positive or negative. The other thing that was really nice about standard form was that it helped us to find the intercepts. Not to say you can't with the others, but it helps us nicely. If we have it, like the value of it is that I don't need to switch to a different form, right? You can just say it's where x equals 0. So you're like, basically your intercept is going to come from the y, it's going to be 0, and then your y value would be c over b. When you have y equals 0, you're going to end up with c over a 0, right? And I don't know if c is positive or negative. You would have to like kind of figure that piece of it out, but it's this c. The other thing this is, if you wanted to find the slope, we talked about how it was, and this came up when we were doing systems as well, the opposite of a over b. We talked about linear transformations, which was a big one with point slope, right? And we talked about what happens with that center point. And even though it's a strange concept, because it's a line, there's no center, right? It's that point that started at 0, 0. Where does it go? Is the line steeper, or is it flatter? Is it, which means is it a vertical stretch or vertical shrink? Is it a reflection over the x-axis? Does it go up or down? Like, is it increasing or decreasing? So it's from the parent function. Use that graphing form, right? Like m is going to change how steep or flat it is. The vertical stretch versus vertical shrink. Parallel and perpendicular lines. Characteristics. Whoa, sorry. Oh, darn. Sorry, guys. I didn't mean to. I got click happy. Parallel, it's okay. Parallel or perpendicular lines. So this one, you're looking at the slope, right? If it's parallel, it's going to have an equal slope. If it's perpendicular, its slope is going to be opposite reciprocal, right? Flipped and negated. If it was negative, it becomes positive. Positive becomes negative, and the fraction flips. Reciprocal, right? Just like instead of dividing by a fraction, we multiply by the reciprocal. Think about what you did there. Characteristics, so we talked about things like domain, talked about things like range, increasing versus decreasing intervals, right? And for a line, it was either increasing or decreasing, so that happened over the entire domain. We talked a bit, not too much, but we introduced the word continuity. And a linear function is continuous. What else did we talk about? Extrema, which again, we introduced this word, but for a linear function, there aren't any, right? This is like a minimum or a maximum, local or absolute, which we're just introducing some of these terms. And as we get farther more into different functions, you'll work with them more. What other characteristics were there? I think that was generally it, right? Here's a list. And then we talked all about absolute value functions, right? Which is the most famous piecewise function. So the parent function, and the transformations from the parent function. So the parent function is y equals a x, absolute value of x minus h plus k, right? Where h and k are at 0. 0, 0. That's your vertex, that middle point. So the transformations, like, is it wider or is it narrower? Meaning, is it a vertical stretch or a vertical shrink? Is it a reflection over the x-axis? Right? So if I gave you the function and said y equals negative 1/2 x minus 2 plus 3, the transformations here would be it reflects over the x-axis. It becomes wider, which means that it has a vertical shrink. It's not as tall from the parent function, right? We're comparing it to the parent function, which is just y equals the absolute value of x. This would translate right to, and it would go up 3. That negative 1/2, so that's going to indicate to me, and I already wrote this here, that's going to be the slope to the right of the vertex. Because really it's a piecewise function with 2 lines that have a restricted domain. It is continuous though. Right, so reflection, vertical stretch, translations. Graphing form, the axial intercepts, right? So your y-intercept happens when x equals 0. So just paying attention to the fact that an absolute value always equals to a positive value. It is absolute value. It's like distance from 0. It's not like distance from 0, it is. So if I had this one, I would just be doing y equals negative 1/2 times the absolute value of 0 minus 2 plus 3. Y equals negative 1/2. That's just 2. To get rid of those the absolute value signs, I'm doing 0 minus 2 is negative 2. Absolute value of that is 2 plus 3. Oh, that's just going to give me negative 1 plus 3, which is 2. Right, so my y-intercept would be 0, 2. For the x-intercept, it's good to picture the graph. We want to know what our algebra is telling us. Right, so, okay, this opened down, so it went right 2, if you picture it, right 2, up 3. Oh, there's going to be 2 x-intercepts. So I'm going to get 2 x-intercepts. It is good to picture it, but we do want to know what our algebra tells us. So I'm going to set it equal to 0, negative 1/2, x minus 2 plus 3, minus 3 times negative 2. So I'll get 6 equals the absolute value of x minus 2. This is where I'm going to get inside those absolute value bars. X minus 2 could have equaled to 6, right? The absolute value of 6 is 6. Or x minus 2 could have equaled to negative 6, because the absolute value of negative 6 is 6. So I'm going to get that it could have been 8, or it could have been negative 4, right? So 8, 0, or negative 4, 0. The points. Be careful that you're not writing it as a line. Characteristics, so again, like domain and range. right? This one, the domain would always be all real numbers. This would always be continuous, but the range is not, right? The range is not going to be all real numbers. Think about like what you know about. So like you got to look at the vertex and see, well, is it going from the vertex up or the vertex down? So like for this one, well, it's the vertex down. So I could say something like y is less than or equal to 3. Or I could say negative infinity. Sorry, I'm having some computer issues. To 3, including it. It is continuous. It has an increasing and a decreasing interval, right? It increases from negative infinity to what's the x value of, because it's like a where. So it stops increasing at 2, right? And then it decreases on the rest of it. And then it's decreasing from 2 to infinity. For as far as these brackets go, I usually always do parentheses because at this point, that's like its turning point. If you would like to include it in one of them, that's fine. Just be careful. I wouldn't necessarily include it in both, but it's not as critical as like when you're doing domain and range. Okay, so as long as you're not saying infinity is included, you're fine. I wouldn't stress it. Okay, so then we got into piecewise functions. And again, like piecewise functions can be any function, and as we move on through other functions, you will see piecewise functions again, but they are functions, meaning they pass the vertical line test. So we're just doing linear, so you're going to have several linear functions that have domain restrictions. So, right, absolute value is the most famous one. You've got domain restrictions, function notation, solving algebraically, and solving graphically, right? So oops, sorry. Oh my gosh. I wanted to get it all up there. So I could have something like f of x equals, and I could have several things going on here. I could say it's x, where x is less than or equal to negative 4. It could be 2x plus 6, where it's negative 4 is less than x is less than 8. And then it could be negative 1/2 x, where x is greater than or equal to 8, right? So it's not including it. And then, you know what? I could tell you to do it graphically, or I could say something like, hey guys, what is x of 8? And you would need to recognize that I need to do this in the third one, right? Because that's where it's in the domain. So I would have negative 1/2 times 8 equals negative 4, right? I could ask you, what is f of 5? And you would need to recognize that that is in the domain right here. 2 times 5 plus 6 equals 10 plus 6 equals 16. Right? To graph it, you just need to recognize where's the open circle and the closed circle. So x, where x is less than or equal to negative 4, 1, 2, 3, 4. 1, 2, 3, 4. Negative 4, it's including it. Negative 4, and it's where it's less than that, so it's like I would have negative 5, right? And my line goes this way. Then in the second one, it's between negative 4 and 8. So when I plug in negative 4, it's going to be negative 8 plus 6, negative 2. Negative 4, negative 2, that's going to be an open circle. Let's do that, negative 4, negative 2. So that's what allows it to pass the vertical line test. And then I'll go to 8. When you plug in 8, you get 16 and 6, 22. That's really fun. I'm going to go up here. It's not including it. 8, 22. The best it's going to get. When I go and I plug in 8 here, we did that one. We get negative 4. So 8, negative 4. That's where you got a closed circle. 8, negative 4. And then what's my slope? Negative 1/2. So I would go down 1, right 2. And there's my line. There's my rest of it. Right? So solving algebraically, this is what I mean. Other piecewise functions, you're not going to be assessed on other piecewise functions. I just think it's important for us to recognize that just because we're dealing with a piecewise, it doesn't have to be linear. If you want to challenge yourself, I don't think it's ever a bad idea to be like, well, what if I made this x squared? Right? Could I do that? Oh, isn't that just going to make it Like what's that going to do? When I plug in -4, what's that going to look like? When I plug in -5, what's that going to look like? So I do think it's important to recognize that they don't have to be linear. Okay. Solving graphically, I just mean going over to if I gave you the graph and I said, what is f of 8, or what is f of -4, I'll go with, knowing that I can go over here, I'm not going to go to this point right here. I'm going to go to this one down here, and you're going to get -4. Okay, function notation, just knowing what it looks like over here, that we are dealing with a function. Domain restrictions, pay attention to them. And knowing that absolute value is a piecewise function is just the most famous piecewise function, so it gets its own name. This would not be continuous. Whereas an absolute value function is continuous. This is not, right? I'm going to draw it, pick my pencil up, and draw the next part. So from this, and we've got two more things we did, right? We did 2x2 systems and we did 3x3 systems, and that was what we've done most recently. So 2x2 systems, remember you can solve them graphically. This isn't really what we're talking about right now. This is something you've done in the past. But what it would look like if you graphed a 2x2 system, if there is one unique solution, meaning it is independent consistent, it would have a point of intersection. You have two lines crossing. Substitution and linear combination were really our big focus. So linear combination was the add down method or the elimination method. So what type of solution? Independent consistent, dependent consistent, or inconsistent? And recognizing that independent consistent should be expressed as a point. Dependent consistent should be expressed as a line. And inconsistent is the empty set, right? So this is 1, this is infinite, this is none, right? So knowing those pieces of it. These are really the two that we are looking at. This is good, but not tested, right? Because we're not using calculators. We haven't done things with calculators. That'll come later. So I put up 2 practice problems here. I would maybe pause the video and try them. I'm going to choose to do the first one with add down and the second one with substitution. I think this is great. Like I'm going to do add down, but maybe go back and see like if I was told to do substitution with this, how would I do it? Because you can do substitution with anything. So I'm going to multiply this first one by 2, and that will give me 14x plus 8y equals 22. I'll subtract so that I can get y to cancel. And I'm going to get, what is that, negative 9x? Yeah. 5 minus 4b, yeah. Equals 4 minus 22 is going to give me, is that negative 18? So x would be 2. I'll go ahead and substitute that back in. So it doesn't matter which one. I'll go 7 times 2 plus 4y equals 11. 14 plus 4y equals 11. 11 minus 14. Is my math right? I certainly hope so. 4y equals 11 minus 14. 11 minus 4 is 7 minus 10. Negative 3. Is that right? Y equals negative 3/4. So I should get a point that is at 2, negative 3/4. And that's independent consistent. Is that right? If I plugged in 2, if I plugged in 2 to this one, I would have gotten 10. 4 minus 10 would be negative 6. Negative 6 divided by 8 is also negative 3/4. So yeah, I'm good. Okay, so that's linear combinations. For this one, I'm going to do substitution. So I'm going to go ahead and add y. So this is x equals y minus 3. And I'm going to choose to put this in the place of x. Negative 3 y minus 3 plus y equals negative 7. Negative 3y plus 9 plus y equals negative 7. Negative 2y plus 9 equals negative 7. Subtract 9 equals negative 16. and y would equal 8. So then I would go ahead and I could plug that back in. I would just go right here and plug it in. X equals 8 minus 3. You've got it set up for yourself. X equals 5. So I'm going to get a 0.58 is going to be their point of intersection. And that is also independent, consistent. Wonderful. There's a lot of this in the textbook, right? So I had assigned some textbook work for you. You can go back to those textbook pages and those archived pages to see what other ones you might want to pull out to practice. The odd answers are in the back, so those might be good ones to practice. And finally, we did 3x3 systems, right? And so here we did this with linear combinations. It's like a combination of both, of elimination and substitution. How do you express your solution, right? Is there no unique solution, or is it a point x, y, z? The types of solutions, independent, consistent, or I apologize, we're not going to do this, right? It was no unique solution. So I've got an example right here for us to try. So remember, what I do is I like to organize my work, and I like to do this, and then say, okay, step 1, so I can follow what I'm doing. Go into it with a purpose. My goal, there's nothing that I'm going to get rid of like super nicely. I think I'm going to try to get rid of Z, and I'm going to start with B and C. I think that's if this just has a coefficient of 1. So negative 2x plus 5y plus z equals negative 4. And 3x minus 4y minus 3z equals 7. And I'm going to multiply this through by 3. So it'll give me negative 6x plus 15y plus 3z equals negative 12. 3 minus 6 is going to give me negative 3x. Negative 4, I'm adding, right? Negative 4 plus 15 is going to give me 11y. These go away. 7 plus negative 12, or 7 minus 12, negative 5. And I'll star that. And I'm going to come back to that. Okay, so then in my second step, I know I need to use A. What else am I going to use? So I'm going to choose to use A and C, because I think that's going to be the nicest one down there to be able to get rid of Z also. So negative 2x plus 5y plus z equals negative 4. And A was 5x plus 6y minus 5z equals negative 1. I'm going to multiply through here by 5 this time. So negative 10x plus 5 times 5 is 25y plus 5z equals negative 20. And I'll go ahead and add down and give myself tons of room. That goes away. 5 plus negative 10, or 5 minus 10, gives me negative 5x. 6 plus 25 gives me 31y. Negative 1 plus negative 20 gives me 19. Okay, so now I'm going to use those two in step 3 up here. Negative 3x plus 11y. My computer might need a break after this. A little painful. Minus 5x plus 31y equals 19. Okay, so it's not all going to cancel, but my next goal, I think I'm going to try to get rid of x. I'm going to have to change both of these. I'm going to have to multiply through by 5 here and 3 here is what I think I'm going to need to do. So I've got negative 15x plus 55y equals negative 25. Negative 15x, 31, 62, 93, plus 93y, that's fun, equals 57. 10 times 3 is 30, 9 times 3 is 27, and add them. Okay, so I'm going to subtract because I need these two to cancel. My x's, subtract. So 55 minus 93, what's that? Negative 38. And then negative 25 minus, is that a 57? Is negative 82? Like, not convinced my math is right. Am I getting y is 41 over 19? Because it's 82 over 38 and divide them each by half? That's ugly. Did I do this all correct? I did b and c. Negative 2x plus 5y plus z equals negative 4. And I multiplied through by 3. 3z, negative 12. And that was 3x minus 4y minus 3z. Those went away. And I added down. And that gave me negative 3x plus 11y minus 5. That should be fine. And then here, I did a and c. And so I had 5x plus 6y minus 5z equals negative 1. Negative 2x plus 5y plus z equals negative 4. And I wanted to get rid of z again, so I multiplied by 5. Negative 10x plus 25y plus 5z equals negative 20. And I had to add them, right? So 5 plus negative 10 is negative 5. 6 plus 25 gave me 31. And negative 1 plus negative 20 gives me negative 21. Can I fix that? 21 times 3 is going to give me 4263. Negative 25 plus 63 gives me 38, which makes more sense. See how I problem solved that? I knew something didn't seem right, and then I showed all my work. And so I just got that y is what? Negative 1. That makes more sense, right? So I've got y is negative 1. Let's see. So then I can go ahead and I'm going to plug that back into something that doesn't look too messy, like this one right here in step 4. Negative 3x plus 11 times negative 1 equals negative 5. So you've got negative 3x minus 11 equals negative 5. Negative 3x plus 11 equals 6. So x is negative 2. And then finally, number 5, my last step, I've now got x and I've got y. I'm going to go ahead and plug it into, I think I'm going to go with c because z is already by itself. So negative 2 times negative 2 plus 5 times negative 1 plus z equals negative 4. So you've got 4 minus 5 plus z equals negative 4. Negative 1 plus z. Come on, computer, you can make it. It's like another 2 minutes. Equals negative 4. Add 1, and I get negative 3. So I got z equals negative 3. I believe, right? Add 5, 1, but yeah, negative 3. Sorry, God, that's a z. Negative 1 plus z equals negative 4, and then when you add 1, I get negative 3. So I need to express it as a point, x, make sure you go in order, y, and z, alphabetical, and this would be independent consistent. I think this is an independent system. Amazing. And there's, again, like more, you guys have resources on this as well to go back and practice and review. So what I just did in this video was I reviewed all of the things that we have covered thus far in Unit 2. Nothing in this involves a calculator. I encourage you to go back and like look at the archived pages and look at the old resources. We have not done too much in Unit 2. We actually haven't finished Unit 2 technically, but we are going to assess on this because we want to save calculator stuff until after this piece of it. So the next time we see you, you all have your last unit assessment, Unit 2, for marking period 1. So just make sure that you also submit your Unit 2 little review book before. I encourage you to do that maybe like the night before you actually take the test. So thanks for watching, and we will see you next time.